In a second, we'll get into today's cool space news story. But first, I want to say I'm excited to announce that today is the 500th video on the channel. And over those 500 videos, we have covered all kinds of space and astronomy news and events. A good chunk of those have been shorts, but even a short takes 2 or 3 hours to make with all the research and editing. So I think 500 is a milestone worth celebrating. If you enjoy the channel and want to support my mission of space science outreach and education, please consider subscribing to the channel and dropping a like on this video. If you want to go a step further and help me pay my bills, there's a link to my Patreon in the description where you can not only support me but get access to exclusive content. Now let's get into today's news story, which takes us to the incredible Nancy Grace Roman Space Telescope. The Roman Space Telescope, or RST, will launch in mid-2027 on board a SpaceX Falcon Heavy launch vehicle and head out to the second Earth-Sun Lagrange point. This is a favored spot of space telescopes like JWST and is a gravitationally balanced spot about 1.5 million kilometers beyond the Earth on a line between the Earth and the Sun, as you can see in this illustration. Spacecraft can orbit this point, burning minimal fuel, allowing missions to last longer, and it also means the Earth, Sun, and Moon are always in the same direction, allowing unobstructed views over much of the sky. RST will carry a 2.4-meter primary mirror into space, along with 2 science instruments. The Wide Field instrument is a 300-megapixel multi-band visible and near-infrared camera that will give super sharp images over an impressive field of view of 0.28 square degrees, or 100 times that of the Hubble Space Telescope. This instrument will be able to perform wide and deep surveys of the universe with the goal of probing the growth of structure in our universe and ultimately giving us a new window on the mysterious dark energy. Dark energy makes up about 68% of the mass energy of the universe, and we still know very little about it. The second instrument is the coronagraph instrument, and this will allow RST to directly observe exoplanets at visible and near-infrared wavelengths. The nominal mission lifetime for Roman is 5 years. Now, you might be wondering what all that background information was leading up to. Well, it's this. NASA has just released plans for RST to perform a massive survey of tens of billions of stars in the plane of our Milky Way galaxy as part of its mission. The survey will cover about 700 square degrees on the sky, and remarkably, it will only take RST about 29 days spread over the first 2 years of the mission to perform the survey. You can see the proposed survey area in the infographic from NASA on the screen. By studying billions of stars in all different stages of their evolution, we'll gain a much better understanding of the way stars form, what causes the clouds of molecular gas and dust to collapse to form the stars, how the environment they're born in affects their lives, and ultimately how it affects their later stages and deaths. Around 75% of Roman's observing time is already set aside for 3 core surveys. The High Latitude Wide Area Survey that will map billions of galaxies to attempt to understand how dark energy affects cosmic expansion. The High Latitude Time Domain Survey that will search for Type 1a supernovae to accurately measure cosmic distances. And the Galactic Bulge Time Domain Survey that will use gravitational microlensing to discover and categorize exoplanets. In addition to these programs, around 25% of Roman's time is open for astronomers to propose general astrophysics surveys that are scientifically interesting observing programs uniquely well suited to the telescope's capabilities. This Galactic Plane Survey represents the first of this type of survey that's been approved for inclusion in the RST program. There's an almost unlimited number of ways you could think of using this new data to study our galaxy and the stars and structures that we find in it, and one really cool feature of Roman means that you could do just that. All of the data from RST's core programs will be available to anyone that's interested in downloading it. In addition to the development tools and pipelines and data analysis software will all be open source and available to anyone in the community that wants to use it. That's a quick overview of the Nancy Grace Roman Space Telescope and this first new general astrophysics survey that's going to be included in the observing program. It's an amazing new space telescope, and the total cost for the whole mission is just $4 billion. That sounds like a lot, but when you consider the science that we'll be able to do and compare it to other space telescopes like JWST, it is significantly less expensive. JWST is expected to come in around $12 billion when all is said and done. That's today's video. Please drop a like and subscribe to the channel if you enjoyed it, and I will catch you in the next one.